Are you stressed out by your Wi-Fi reconnect logic? Your device stops talking to the internet and you don't know if it's because you were supposed to call Wi-Fi reconnect or if calling Wi-Fi reconnect actually interfered with what's already happening in the background. It's supposed to auto reconnect, right? It usually does, but sometimes it doesn't. Well, you can always call reconnect, except you shouldn't call it too soon. Or maybe call it once and then wait. And wait how long? 5 seconds, 10 seconds, 30 seconds. Sometimes it feels like everyone's guessing. I got tired of trying to Google my way through it, but I knew the one thing I wasn't doing was looking at events. Wi-Fi status is downstream of events. If you are relying on Wi-Fi status to find out if you're connected, you're not really getting all the information. Status is set by events, and events are where all the action's at. I converted to events and started logging them. When you get a disconnect event, it also gives you a reason. I started logging those. I walked up and down this hallway for a couple days, watching the patterns, trying to understand when does this device reconnect and when doesn't it. At the end of that, it was indeterminate. I was about to give up, but I looked at the Wi-Fi.h code base one more time. And in one of the files right at the top, I found a keyword that led me to the actual code block where the reconnect logic is being driven. What I saw there actually corroborated what I was finding in my hallway walks. If you want to build yourself a next level Wi-Fi library, I think you should know this stuff because there are times when the device does not reconnect because it is programmed not to. We can handle that though. We can change the pattern. If you stick around this video, I'm going to show you how you can program your ESP32 to always reconnect, but do so in a way that is in harmony with what the system's doing in the background. A couple weeks ago, I created a Wi-Fi library that logs events and status. I'm going to pull that down and give you a quick overview. We're going to take that as a starting point, and we're going to incorporate our findings today into that library. Then I'm going to take you on the actual research trip, the trip up and down the hall where I was watching the Wi-Fi status, see how it behaves as we went out of and into range of our Wi-Fi connection. Next, I'll show that what we found in the hallway really correlates well with what you find in the documentation. In the code, I'll show you the actual location where the reconnect logic is handled. That gives you some idea on how we should be doing things differently in our library. With that information, we will refactor the library to incorporate our latest best reconnect logic. Then I will wrap it up, which means show that this code will work with Arduino and then push it into GitHub. If you're not familiar at all with Wi-Fi events, check out this video I'm posting in the upper right hand of the screen. You can click here to go to my ESP32 Wi-Fi Introduction to Events. Let's pull down the repo and I'll give you a quick tour. This is the code from the Introduction to Events video. You see there it is in our directory. I'm going to move that into Wi-Fi Labs. CD in and open VS Code. This is a Platform IO project, but this code will absolutely work with Arduino, so stick around at the end. I will show you that it works with Arduino IDE. In main, we're making 4 calls to our library. We're going to tell it to log the events, and then we're going to begin our Wi-Fi connection. Then we're just going to log the status. You see that we're also using Wi-Fi tools.isConnected as a Boolean to tell us whether or not we're connected, but we're not running any code there so far, and we're not going to today. I'll set my credentials and compile, and this should give us an internet connection. You can see on top we're logging the events, and then down below we're logging the status on a 1-second interval. We also get the RSSI, which is kind of nice. This log status function, it's in the debug file. You see your log status, it's on an interval which is in the header file. We're logging on a 1-second interval. Then back in main, we're calling log events, which actually sets a Boolean to true. That Boolean is used here to tell us, yes, go ahead and log those events when they come in. In Wi-Fi tools begin, before we call Wi-Fi begin, we tell Wi-Fi to, on an event, call the event handler. That's what we saw down below. We've got our event handler, and then if the Boolean is set to true, we log events. Below, we're taking 2 events. When we disconnect or when we connect, we set that isConnected Boolean, which is being used up front. I think that's all you need to know for now. What we're going to do is turn our attention to this placeholder which has not been propagated. We need to answer the question, how do we want to handle our reconnect? That opening shot that you saw of me going up and down the hallway at the beginning of this video was quite real. I spent a couple days walking up and down these halls and revising the code to try to understand how this library was working. First thing I found out is that simply unplugging the router never breaks the connection. It will always come back. I unplugged the router. You soon see the disconnect message. I plug it back in, and you eventually see that it reconnects. You see this here once. I saw that happen about 12 times. Next thing I found out is when you get Wi-Fi status 4, you never come back. You see that it's coming back here because I just called reconnect after waiting 10 seconds. Wi-Fi stayed disconnected. I'm logging the event, but at this point in my logging, I haven't yet added the reasons, so I'm going to do that next. When I add the reason, I find out that the status code of 4, which is fail, comes when we get the disconnect event with reason code auth fail. That's the only time I saw it not reconnect, so I thought, hey, maybe I found something. Status code 4 means total failure. It occurs when you get an event of auth fail. The next day, I set out to confirm my hypothesis and could not, because I never saw another status code 4. I did, however, get random states that would never try to reconnect, and they always coincided with the reason of timeout. Okay, so I've discovered 2 reasons that the Wi-Fi won't reconnect. But there are lots of reasons listed for a disconnect, and until I see them, I don't know if those are reasons that prevent me from reconnecting. As I mentioned, I really was feeling like it was time to give up. I came back into the Wi-Fi.h repo one more time, and at the top, I see this reconnectable reason. In my introduction to events, we went through the documents and found a list of disconnect reasons. It's quite long. These reconnectable reasons are clearly a subset. If we've got all the disconnect reasons, and we have a list of reconnectable reasons, we can generate a list of unconnectable reasons. And when I zoom in, I see that 2 of those in this list are the 2 reasons I got when the Wi-Fi stopped connecting at all. Let's go look more closely at the code. I search on this term and come back to this function, and we see that we have a Boolean set to false, and if the Boolean is true at the bottom, we're going to reconnect. There are only 2 places where this happens. First is if there's a first connect, which is defined above, and second is if we have auto reconnect set to true and we get a reconnectable reason. It means that unless it's the first connect, if we get a timeout or an auth fail or any of those non-connectable reasons, we will not connect anymore. Let's go in and look more closely at that code. If we scroll up to line 105, we see that this code will execute anytime there's an event. We're setting various statuses until we get down to line 131, where we now handle disconnect events. Here again, we're setting various statuses until we get down to line 150, where we began our actual reconnect logic. I'm going to grab this code block and put it into VS Code for analysis. Give me a second here to rearrange and make some space. We are declaring a Boolean, which is set to false. And if the Boolean ends up set to true, we then reconnect. By the way, this says disconnect and connect. That's exactly what the Wi-Fi.reconnect function does, except the reconnect function returns a Boolean, whereas here, I guess because they don't need the Boolean, they just call these 2 terms directly. We no longer need these. Let me take them off the table. I'll pull out these else's, and I'm going to pull out the logs. So now let's step through and see what we got. How do we respond to this reconnect logic? The first thing it does is if the user actually called a Wi-Fi disconnect, it will not reconnect. We want that, I think, so we should do the same thing. So our first rule is if the user disconnected, do not reconnect. If it's the first connect, then reconnect immediately regardless of the reason. Now I can just tell you above, this is what you think it is. A Boolean was set to true, and The first time we disconnect, we run this code and then it's set to false. At any rate, because the system's already going to do that reconnect, from our side, if it's the first disconnect, we do not want to reconnect. Down here is where we see that if auto reconnect is set to true, which it is by default, then we're going to call those connectable reasons. But we don't only want to reconnect when we get reconnectable reasons. The two unreconnectable reasons that I showed you both occurred when I had proper Wi-Fi credentials and was somewhat within range of the router. In a situation like that, no, I do not want to lose Wi-Fi forever. I want it to try again. So we need to override this line. Wi-Fi reason association fail. This is one of the reconnectable reasons, so we will only get here when auto reconnect is set to false. However, this says nothing about reconnection. It's just setting a status. So let's remove this as well. We don't want to reconnect when the user disconnects. We don't want to reconnect when it's first boot because the system's already doing it for us. However, we want to ensure that we're always reconnecting thereafter. We could write a function that calls reconnect whenever we get an unreconnectable reason, but there's an easier way. Let's just set auto reconnect false, which disables this entire line, and we'll just call reconnect ourselves. Here's the list of steps in the order that I verbalized them, but I don't think it's how I want to think about it in terms of code. Let me rearrange. Let's set the auto reconnect to false. Then we want to make sure that if the user disconnected or if it was a first disconnect, we are not going to reconnect. Otherwise, we are going to reconnect. Let's get these changes into our code. For as hard as it was to get all those answers, I think this next part you'll find kind of relaxing. The code itself is not that complicated. It's pretty straightforward. Our first step is to set auto reconnect to false. We'll do that in Wi-Fi tools begin right before we call Wi-Fi.begin. Okay, one down. If the user disconnected, do not reconnect. Before we code, let me refactor this. I don't want to use a switch case. I want to use if statements. It'll be fewer lines of code. I got this from the previous video on Introduction to Events. You see that our event handler above is receiving an event and info. And if we look here at this path, info Wi-Fi state disconnected.reason, we get the reason we disconnected. Wi-Fi reason association leave means the user called for a disconnect. So as far as our reconnect logic goes, we're just going to say, if we didn't manually disconnect, reconnect. That's it. Next, if it's the first disconnect, do not reconnect. This is again where the system is always going to reconnect regardless of the reason. It's already doing it, so we don't need to. I'm just going to create a Boolean and use that to tell me when it is or isn't the first disconnect. We'll set this to true, and then at the actual disconnect event, we'll just check for it. Only when it's not true do we want to reconnect. After this if statement, we want to send our isFirstDisconnect to false, because from here on out, it will never be true that it's the first disconnect. It may be confusing that I'm prepending Wi-Fi tools to all of these variables. You see that our event handler is part of the Wi-Fi tools class. However, it is a static member of the class. In our source file at the top, we're creating a Wi-Fi tools variable, Wi-Fi tools. But this event handler is not on that instance. Because it's a member of the class, it can see the values in that instance, but it doesn't have contextual access to them. So we have to specify Wi-Fi tools dot every time we call something from the library. Anyway, our third item is complete. Now we just need to tell it to reconnect. I've got the way I like to do it, but I'd admit that even thinking about this again causes me stress because there's so many different opinions on whether or not you should reconnect immediately or wait a while and then reconnect. Because we turned off automatic reconnect, we're never going to be colliding with the system. The only time it's going to reconnect automatically is on the first disconnect, but we've turned that off on our side, so we don't have to worry about it anymore. And because the library itself so many times immediately calls for a reconnect, it can't be that bad. I would prefer to just do it once immediately and then wait thereafter. So I'm going to set up a timer that will typically Fire immediately once and then wait, I'll call it 10 seconds before firing again. If for some reason there's a disconnect in the first 10 seconds where we haven't reached this threshold, it's okay because, as you know, the Wi-Fi library is going to reconnect automatically for us, so we still get that instant reconnect. In my event handler, I want to call some Wi-Fi tools reconnect. In the header file, let me prototype some values. I want to prototype the function, and I want to create a timer variable. Then I want to define a threshold at the top. Let's call it 10 seconds. Now in the source file, I'll define the function, and I'm just going to do the classic timer execution here. If millis minus the timer is greater than the threshold, do it. We'll call Wi-Fi reconnect, and then we'll reset the timer. We fire it up, and we're still in business. Refactoring complete. You now have the best balance between speed and harmony with the native functionality in your Wi-Fi reconnect logic. Let's wrap it up. I want to show this code works with Arduino IDE. You know that Arduino IDE requires your sketch file to have the same name as the folder it's in. Rather than just telling you to import this Wi-Fi tools library into your Arduino IDE libraries, let's put the sketch in this repo. If you're an Arduino IDE user and you pull this repo down, you've got your Wi-Fi lab sketch right there. There's something I have to handle though. On top here where it says include Wi-Fi tools.h, that will work in Arduino IDE when you've copied the Wi-Fi tools library to your Arduino libraries folder. But until then, we can still access those files directly here in this sketch by writing the path to each of the files. I'm going to add some documentation, make some space so you can see everything. I'm going to open this up in Arduino IDE and compile, and it fires right up. We are now officially Arduino IDE friendly. Okay, I wasn't recording, but I just sent this up to GitHub. So all the code you see here is now available at the link in the description. There. And with that, you can now sleep at night knowing your devices are going to stay connected. I really did walk up and down the hallway in 100 degrees and high humidity trying to get these answers. If you appreciate that effort, please remember that it doesn't cost you a dime to like or subscribe, but it would help me out. I'm Larry. Catch you next week.